Welcome to Community Update 190. There's not a huge change on the networks as of now, but one update there is the O12.2 RC1, and that was running on the testnet for a while. We'll probably promote that to all the nodes on the mainnet shortly. That's the one thing that is new in the networks. And just to remind people, O12.2 basically has some bug fix or improvement in the transaction API. That is the difference. In terms of the other thing about the networks is that I think yesterday we had a mainnet node slashed due to tuple space error. Now, this is something that we run into every once in a blue moon. I remember several months ago, I said, yeah, this is something we see once in a while, but it's not really easily replicable. And I think it seems like we ran into that again now with the tuple space error. There was a time way back when that it was more frequent, but we had not run into this in several months each time in between. Since the mainnet. So, like I said, it is hard to replicate the error. We're not in our tests. For now, what we're thinking is that we might put in a fix to replay, run the replay one more time when such an error occurs, because the thought is that this probably is some very weird thing about asynchronous computation. So we'll try that anyways and test it and see if, again, when I said test it, this is a several months test that we have to be running. So we'll monitor behavior after the fix and take any additional action we need to after that. But that's the plan for that for now. Coming back to the content of work of what the team has been working on. Nutzipper is continuing to identify and resolve any logical inconsistencies potentially, or this is looking for those, or any bugs in the leaderless state merge, and he's making good progress. I think he hopefully in the next maybe by early next week we might have a release that we might have a testnet, we may be ready for testing on that. That's the thinking at the moment. Tomislav he is going to give a presentation today about the work he's been doing. He has temporarily switched to troubleshooting why the linear scaling is stalling after, whether it's 40, 45 nodes or after a certain number of CPUs or cores that we provide to it. So you'll see a lot of details from him, but while the stalling issue as to the exact sources and the quantum of contribution from each source to the stalling is at this point inconclusive, we just wanted to present the amount of work that goes into analyzing the problem and looking at it from multiple angles and to characterize it. So that A, we can identify the main areas that are suspect, and B, within those areas, what is the machinery, what are the issues that are causing those problems. So Tomislav is going to present that today. And I think he's got some also a couple of options he's playing with that he'll speak to. But I think soon Tomislav will be reverting to working on the merging of rev balances like he was doing before. Just to remind the members, Tomislav had presented in the last session much of the merging of rev balances work, but except for rejecting the cases where there might be double spend. So that's the piece that is yet to be done, rejecting double spends, and that's what he'll be getting back to shortly. And then there is ongoing work to refactor the tests in finalizing the leaderless block merge. And that's something also that's going on. Dennis has completed, or not completed, but basically his PR is in for radix tree implementation of history. And that has the performance data for reads, deletes, and insert operations. He's seeing about a 30% improvement with his things. But in terms of the full or actual impact of the improvements, once we merge this into the code base, we'll see how much of an improvement that results in. That's what's going on there. And we are talking to one more resource to be added to the team. So we're very excited about it. It seems very competent. So assuming we can work out reasonable terms, we may be adding him to the team soon. That's where we are. I think that's the crux of the technical update. Before I turn it over to Tomislav for his presentation, are there any questions or comments on any of this at all?
I just want to add that Art and I resolved this bug that we've seen in the merging of rebalances. So I think this part is now working. So I'm happy for that.
Yeah,
we see that. Yeah, we have nodes running.
Yes, exactly. Yeah, and so thank you for pointing that out, Tomislav. So Nutzipper has been running the road. I mean, I said we're getting close to compiling the node or whatever. So the node has been compiling and is running, and the things are progressing. It's just that we're looking for any other potential logical issues in there. That's what he's working on. Thanks for pointing that out. Anything else? Any comments or questions from anybody else?
If I may also add, for a new history that Dennis is working, this is also this 30% improvements is overall, not just for the history itself. So we see that the block production is 30% faster, and the changes in the history is also something that we are preparing so that rev vaults can be directly stored in the history without tree hash map in rollup. So this is very important in multiple levels, because we can optimize pre-charge and refund, and we can optimize, for example, the work that Raphael is doing with RChain token, because he's using tree hash map, which is now used in Revolt. So optimization in the history is very important. This is why we are preparing this for hard fork 3.
Mm-hmm. Very good. So Tomislav, why don't you take us through the performance improvement work, and I'll stop sharing.
So I was thinking how to start to show this performance testing, and maybe the best is to start from the final result, because I have lots of testing that I done, and so at the last stage I was testing different Java runtimes. For example, with the Graal VM and Java 11, and this is little unexpected, because previously we didn't make any detailed tests, but we didn't see any improvements. But now with testing just the rolling execution, there is some improvements with Graal VM, and so I also want to show on this graph where we see the problem and why we are doing this performance testing. So on x-axis is number of parallel rolling executions, and on y-axis is the number of COM events. So and this test is done on 128 CPU machine. So this is large machine where we basically want to show that we have linear scaling. But something is going on after maybe 16 CPUs. There is nothing magical about this number, but something happened with this number of threads. And this is probably what we are suspecting now, something in JVM, where basically JVM is trying to, I mean, this is what we are suspecting, that JVM is trying to, or JVM is not able to use optimizations that are usually used when dispatching methods on classes. For example, we'll find out in relation to GraalVM that they were able to see some degradation in performance when JVM is used with Scala or some other libraries that have abstraction over runtime, and we are suspecting that this is the case. So what we see here, we have linear improvements until these 16 CPUs. After that, performance is very speed up is not linear and goes very slowly until the point where we have the number of threads equal to number of CPUs. After this point, of course, we cannot have greater performance. So I want to show also a few of other tests. What I was trying to analyze what is going on. So, for example, so this is done with Monix runtime, and this is what we are using in our on top of JVM. We have few other options, and this is directly Katz effect IO, which is like a reference implementation of Katz effects, and Zio as another option. In testing, Zio didn't behave very well. So Katz effects IO has a similar performance to Monix, and this is visible here. So this is the latest test I did, and I was trying different Java thread pool options, and with fork join thread pool, Monix and Katz IO behave very similar. I also tried a few other things with fixed thread pool, and I didn't see any difference in linear scaling. Only different performance. So the conclusion is that right now we are using the best what we have, what is available. At least with Katz effect 2. Katz effect 3 is now out, and they are claiming that their IO runtime is like much better. I'm not sure if it can be better than Monix, but we cannot test this because for upgrading to Katz 3, we need to do some more refactoring. First, we need to go to Scala 2.13, and this is the biggest step. So after that, it will be much easier to go to Scala 3 and Katz effect 3. I'm not sure if you are interested in all the immediate steps that I was testing. For example, I was testing with different buffer used for communication between the storage and the RSpace. This is only possible in memory, but I didn't see too much difference. Also, I have different machines. If, for example, here, if each core is faster, we see improvement in performance. Here I have a test between Java 11 and Java 17. I didn't test on large machine. I was not able to install the Java 17, so I will test this also. But on my machine, I didn't see the difference. I also tested with. So my machine had 16 CPUs, so I tested like just different number of threads. So without using all of the CPUs, and results as expected. The performance is growing until the point where the number of CPUs is equal to the number of threads, and all the other stuff is not like interesting. I think this is all that I want to show.
Thank you very much, Tomislav, and I really appreciate the work that you've done in documenting this. The Graal VM data is actually interesting. We didn't see that this morning, so this is quite interesting. But again, it's almost as if the JVM, you know, it's like they said, okay, let's make it work for 16 cores, and then after that, nobody ever gets more than 16 cores. Yeah. I mean, just to give some more color to folks who might be interested in the technical background, the article that Will posted shows that, and this is you know, evidenced in our own flame graphs that Will created earlier, is that the JVM ends up spending a lot of time in dispatch. So it's trying to essentially, for implementations that use the monad type class, the JVM is spending a lot of time in dispatch, trying to figure out basically which method to call. And the problem is that because Java is reflective, you can at runtime update how dispatch happens. So you can change things about the dispatching. And so my guess is that dispatch has to take a lock, which means that while you're in the dispatch code trying to figure out which method to call, all the threads are blocked. So that would create the kind of contention that we're seeing. And so there are some solutions. Again, this is just a hypothesis, but this is, you know, spending about 30 minutes with the data this morning. This is what I was able to ascertain, or, you know, come up with. And so, you know, we have to check to see whether that hypothesis is correct. But if the hypothesis does bear out, then there are some solutions potentially without jettisoning the JVM that we can look at. You know, in the worst possible scenario, we'll just say goodbye to the Java VM. We were going to do that eventually anyway, and if that's what it takes to start accessing the performance of the hardware, that's what it takes. But you know, first we're going to do our level best to make sure that we don't have to take such drastic measures. But I really appreciate you digging in, Tomislav, to see exactly what's happened. And again, for people who are maybe less skilled in the art or less experienced with this kind of stuff, the summary is that we're seeing the kind of scaling that we expect up to about 16 processors. And then beyond that, the overhead of the coordination amongst the threads is eating up all of the scaling that we should be getting by adding more processors. So we're trying to figure out exactly who is responsible for for that bad coordination behavior, and whether it's our threading package or the JVM, or could it be the hardware itself, right? It could also be just that the hardware is not optimized for this kind of intensive use of cores. So right now, everything points to that it's the JVM. That's as opposed to the threading package per se. So we have to dig in and find out more. But that said, we're still getting quite respectable numbers as long as we can optimize the pathway. You know, like if you look at Tomislav's graphs in the absolute perspective, as long as we can optimize the So it looks like you're getting about 15,000 comma events per second at the spikes above
Yeah, with Graal VM.
with the Graal VM at about 36 processors.
Or just say on average, maybe more like 14,000 is what probably is hitting. Right?
Yeah. So again, we have to take these numbers with a grain of salt because Tomislav has gotten a lot of code paths out of the way. But assuming that we can optimize in a way that is roughly equivalent to what Tomislav has done to get certain code paths out of the way, then we're looking, let's say on the low, let's take the low end of that, say around 10,000 comma events per second, which is fairly respectable, right? It's the target. It's what we were targeting for per shard, right? We wanted about 10,000 comma events per shard, and then you need 4 shards to get visa level speeds. So that was always our target, and I think we can hit this without too much too aggressive refactoring, like getting rid of the JVM. So I mean, it's within striking distance, but what we really want to do is figure out why we're not seeing the linear scaling that we should be seeing. Any questions or comments? Go ahead.
And with the linear scaling, for example, we can go to 40,000 com events per second, even maybe with 30 CPUs.
Yeah.
If you are following this line, which is like, yeah.
Yeah, exactly. So we just need to find out who's responsible for the dramatic slowdown. And right now, all fingers are pointed at the JVM. But any questions from anyone else? Questions, comments? Okay. Was Nutzipper going to give a little chat?
Sure, I can just briefly show what I got recently. So I finally got Casper to work without thinking too much about slashing. It's just I got the code complete about the finalization fringe, and I can show you some pictures. Yeah, so basically this is what I got on a simulation. This particular one was without the proper merging, but as Tomislav said, just like in the recent hours, we figured out what didn't work, and now it looks like merging works as well. So picture is quite promising. And what is shown here is that 10 validators on the network are minting blocks asynchronously. We don't have any synchrony constraint, all just producing blocks with the pace they're capable of. They are replaying concurrently with producing. And this is what we have basically. Red blocks are finalized blocks, which means that 2/3 of the stake built on top of them. So this is the finalized fringe. This means that everything which is behind is finalized. And the green one is in this particular case, this is the least common ancestor of the finalized fringe. But in general, it's, as we said, that some message might be very below if some validator is stale and silent. So in this case, it won't be the LCA, but it will be the highest common message, a bit different thing. But anyways, this is the point where the history of the blockchain converged. So everything went through this base, and to merge reds, these partial finalized states, we have a algo for merging them through this base, and by accumulating the blocks that are not inside this base state but should be. So these, as we can see in the network, these fringes are advancing with the network, and sort of we are pretty close to having something being rolled out on some DevNet, testnet for folks to try to break. So this is it. I'm quite excited.
I am too. This is just the bee's knees. This is so cool. Maybe for people to understand a little bit of why this is so exciting. We don't, the finalization fringe represents the advancement of time. So there's no wall clock here. The validators are operating asynchronously, and yet the red circles represent, you know, the wave of understanding that the state has moved on. The state has moved on. The state has moved on. So it's a kind of, it's a relativistic view of a state change. So the validators are operating, you know, towards a consensus on you know, how time is flowing, which is just absolutely fantastic. So we've been able to maximize asynchrony, and yet have this sort of common view of how time, for lack of a better word, that's really a stand-in for state change, but how time is advancing. So this is super, super exciting, right? None like, you know, in order to get, you know, the fairness considerations and everything else, we don't have to introduce a wall clock, no network services, nothing, no network time service, nothing like that, in order to get this kind of advancement of state, common advancement of state. So really great work to the team, especially to you, Nutzipper. This has been fantastic. So any questions or comments from folks?
Yeah, I also want to say that Anton did a great job.
Thank you. Thank you.
I have two questions. So the green circle, you were saying that is, I mean, this is a complete, you know, programmable cretin question here, but you were saying that is where they all meet?
It's the least common ancestor in this case.
Okay.
So you have partial finalized state. So this means that you don't have a single state, a single block in which you can just point and say, okay, just read me from this block. You have multiple of them. And to get a combined state, you need to merge these reds. And how would you merge this? You need to find some common history, some common point in history. So state of this block is inside all reds because this block is an ancestor.
Yeah.
Okay.
Then you merge into this block something that is about this area, which is finalized blocks that are not seen by the green. This gives you combined finalized state of all reds. But this is the common history for all messages in finalized fringe.
Okay, I think I understand.
Cool.
My other question was, how do you generate these images?
Well,
do you have to manually draw each line, or is it somehow automatically generated?
Previously, folks did good job for making a visualizer. This is the graph viz, a general graph visualization tool. So we have a way to dump our state of the DAG in that format and print it.
I see.
So what you're seeing is an actual run, right? This is not.
Yes, actual run.
Okay, amazing. Nora wrote in the chat, he uses a large loom.
It's very fun. Well, you know, it's another. You just mentioned that, but I just today I had an insight about how to correlate knots or braids. This is a braid, braids and music. So we can potentially turn these graphs into pieces of music.
There you go.
Oh, wow.
And then eventually you'll end up with the sound.
Very good. Excellent. All right. Any other questions for Nutzipper?
Yeah, I had one just to give some perspective. What other systems could you compare this to, or where might you see such a thing as this in other computing or in science or nature? What are we looking at?
Recently, I had a most excellent conversation with Bob Kuka and his colleague at Cambridge Quantum Computing. Mike Stay and I had a meeting with them. We were talking about our work on the space calculus, and they were presenting their work on mobile agents in space and how that relates to natural language processing. And during the presentation, what Bob and his colleague made super clear was, in order to get the semantics to work out, so they were trying to represent, things like the arrangement of chess pieces on a chessboard. And what they had to do was to give every agent who is communicating about the board their own view, and then essentially the quantum representation, the entangled representation, meant that they have forced agreement about certain aspects of the state that are related to observations that are connected to the statements that they're making. So when they make statements that everyone can consent to, then that forces some of the possible positions to be collapsed into positions that everyone has agreement on. So in that sense, what Casper is doing is something like that. It's very close to what's going on there. In another sense, you can think of each validator's view from a given block is kind of like a light cone, right? So it's everything that goes into the justification of that block is what's in the past, and everything that block supports is what's in the future. And each validator is engaged in sending events to other validators, and essentially what we're doing is we're insisting on a causal relationship across the state changes. So in that sense, it really is very much like general relativity. So it has a flavor of quantum mechanics and it has a flavor of general relativity. But with respect to existing blockchains, there's nothing out there that's like this.
What about beyond blockchains, other systems, whether it's in other fields of research, pharmaceutical, biological?
Yeah, like I said, the only thing I'm aware of is the physics analogies. There's nothing in distributed systems that I'm aware of that has this this flavor. I mean, it may turn out that you find mechanisms like the coordination of slime mold. How slime mold is like a bunch of different independent cells, and then when environmental conditions arise, then suddenly it becomes a single organism. And so people have studied this, and for the longest time, people thought that there was some like king slime mold cell that would tell everybody.
You mean like a Markov blanket or Friston blanket? Systems come
not close, but there's some key differences here, right? Typically there's a central control mechanism, right? So the Markov blankets, when they're implemented, there's one guiding process that looks at the whole Markov network, right? Whereas here, each validator is maintaining its own view of the network. So they're separate. So it's much more like, like how is it that the fireflies all flash together? How is it that the slime mold, goes from single cells to this gelatinous thing and then dissolves back and then goes back, right? How is that happening with no king directing them? So from that point of view, it's more like that. The validators are all just following the rules of a particular game. And if they play by the rule, as long as they play by the rules, they don't get slashed. If they get slashed, they're out of the game, so they're not allowed to play anymore, right? But as long as they're all playing by the rules, then they all eventually come to an agreement about the state. So that's really what's going on.
Thanks.
And you can see the thing about the red line is you can see the waves of state propagation. The red line is how state is advancing, right? So it really looks like a wave propagation. This is why I've long wanted to do a quantum based consensus, because when you boil Casper down to its components, it has the feel of being a classical simulation of a quantum system. All right, any other questions or comments before we move on?
Yeah, excellent work, guys. Excellent work. Kudos to the team.
Absolutely, yeah. Darryl, are you ready for the week in review?
Yep, I am. So here's the week in review for Thursday, September 16th to September 22nd today. Last Thursday in the governance committee, we discussed the moderating process for Discord and other forums, and then we went over the proposed IOBs. And we also had an additional 3-hour meeting on Saturday regarding the IOBs. We went over them all in detail. On Friday in the Climate and Coordination RCast, we spoke about the G20 countries failing to meet the Paris Accord so far and the future carbon budget. We also discussed how the shift to the decarbonization economy could play out, which led to Jeremy Rifkin's book entitled The Green New Deal, Why Fossil Fuel Civilization Will Collapse by 2028 and the Bold Economic Plan to Save Life on Earth. I love that title. And Chelsea Green's book, Donut Economics. And then Greg spoke of the impossibility of reaching the 1.5 degree targets and how much of the challenges will be focused on mitigating and responding to the growing onslaught of environmental disasters over the next decade. Let's see, on Monday, the Casper Stand-Up. This week's Casper Stand-Up covered the application of OSLF to a new model of FM set theory. On Tuesday in the communications working group, we discussed prepping for the AGM, the IOB process, the latest situation with the NFT play, and prepping materials for the Dubai event. Also on Tuesday, on Tuesday and Monday in the RDev and DApp developer meetings, they worked on chat, delegates, and rev addressing. And today in the active member hangout, in Jim's room, Jim, who is such a loyal proponent of this call, managed to make the call even though he was literally sitting in a hospital bed. So Jim went in for but he went in for an appointment about some issues he's having with pain in his legs and his connected to his spine, and discovered that he has to have heart surgery. So he actually had the call sitting there in this hospital bed, which is just amazing. And I just want to say, I hope our thoughts go out to Jim. It looks like he's going to be going through surgery soon, and this was unexpected. So we hope him a speedy recovery. And that brings us to now.
Awesome, thank you. Any questions or comments for Darryl? Very good, thank you so much, Darryl. As some people may have seen on Twitter or other venues, we have been invited to head out to Dubai, and we'll be presenting at the AIM conference in Dubai. So I'll be headed out there in mid-October, sort of early mid-October, to give a talk, and we'll be holding a booth at the conference. And so we're quite excited about getting the word out about RChain to the folks there who are interested in that sort of technology. So any questions about that?
I just want to mention I put some links in the chat right now for the AIM Summit. And, if anyone is curious about it, there's some chatter already going on in Discord. And the event that Greg will be speaking at is called How Programmable Money Will Transform the Functioning of Economies. And it'll be happening on Tuesday, October 12th at 11:20 a.m. GMT. And we're also getting a booth at this summit. So kudos to the China team for making this happen in the first place, and all the work that they've been doing right now behind the scenes to rapidly come up with materials for the booth and everything. So yeah, exciting.
Yeah, absolutely. And I also want to give a shout out there. There were some members who stepped up to cover the travel costs of the team that's going. So I really want to express my appreciation for those members. You know who you are. So this is not coming out of the co-op's coffers, but actually being covered by some key members of the cooperative. So many thanks. The co-op definitely is grateful for your efforts in this regard. And a big shout out to the China team, who's been working pretty much nonstop for the last several days to make sure all the logistics are nailed down. I want to point out that the deadline for IOBs is Friday. We have received several IOBs, which the governance committee has been reviewing. And we are offering a session based on what we've seen of the IOBs. We are offering a session for how to write a good IOB. This will be at 3 a.m. Pacific time in order to facilitate our members who are in time zones that are far at the opposite ends of the earth from Seattle. So in particular, there are some key points of guidance. I'll summarize some of them and go into more detail in that session. So if you're going to submit an IOB, it's a really good idea to be familiar with the co-op's bylaws and articles of corporation. So in particular, if you are submitting an IOB that is at odds with the bylaws, it's unless there is strong sentiment from the community, it's very unlikely that the board would ballot such an IOB, and largely because changing the bylaws is a very serious matter, and has to have a significant portion of the community behind it before that would be effective. Also, I want to point out that any submissions that are about undermining the functioning of the co-op so that it becomes a plutocracy or so participation is based on economic position, which devalues sweat equity, devalues all kinds of other contributions that people can make. Not only does that go against the bylaws, but even if there were a referendum and the entire co-op were to vote that way, I would leave. So I want to make that super clear. I am 100% committed to democratic principles as opposed to plutocratic principles. And so if this organization ever becomes about how much money you have in the organization as opposed to how much you contribute, then I'm out. So I want to make that super clear. So those are some of the points that we will be covering in this session. Any questions or comments?
Yeah, I think I put the wrong times in the chat. It's 3 a.m. Pacific for the review. Is that right, Greg?
That's correct. 3 a.m. Pacific.
Okay.
Yeah, I was just going to point out that there is also, I think we're planning a conversation on the IOBs in the member meeting also, right? The closed doors. That's the 11 a.m.
Yes.
Pacific.
So if you missed that one, we will also be going over some of the key points in the proposed IOBs in the closed door session on Friday, which is at 11 a.m. Pacific time.
Okay, so we're addressing IOBs in 2 meetings on Friday. The first meeting is at 3 a.m. Pacific, and the second one is at 11 a.m. Pacific. We're having the 2 meetings so that we can better cover members across the world.
And both those meetings are only open only to members, right?
That's correct. Only to members. Yeah, absolutely. I'm really excited by all the engagement. I think it's wonderful. And I'm happy that there are IOBs that are proposing things that I violently disagree with. That's the whole point of having a co-op, so we can have a vigorous debate and come to and come to higher quality by making the most of our differences. So I'm very excited about the engagement, but I do think that there are a few things that people might want to become familiar with if they want to write a successful IOB. All right, let's see. Let's use the remaining time for any questions or comments from the community. Anything burning, anything that needs to be addressed. Okay, then. Thank you so much for your time and energy and all the hard work that's going into making this the best offering we can make. And please stay safe, stay warm, and see you on the other side.